All right, our lesson 2 note starts to introduce something that you're going to use a lot through 8th grade and high school called proportional relationships. So two quantities are proportional to each other when there exists some common number, okay, or a constant number that each measure in the first quantity multiplied by this number gives you the second quantity. In math, we always look at this as your y over your x. So example 1 says pay by the ounce frozen yogurt. A new self-serve frozen yogurt store opened this summer that sells its yogurt at a price based upon the total weight of the yogurt and its toppings in a dish. Each member of Isabel's family weighed their dish, and this is what they found. Well, we know in math, we always do cost or price per item or over item or amount. So I know my cost is going to be my y and my weight is my x. And we'll be talking about independent and dependent variables later this chapter. So down here, what I need to do is I'm going to look at my y over my x. So I see if I could spend $5 for 12.5 ounces of frozen yogurt. I can spend $4 for 10 ounces, $2 for 5 ounces, and $3.20 for 8 ounces. If I take my calculator and divide each of these in the calculator, you're going to get 0.4, which if you think about it in money, if you think about that in money, that's 40 cents. So true or false is the cost proportional to the weight. True. And the reason why is because it is my y over my x, and that equals 0.4. I could also multiply my x by 0.4 to get my y, because remember, multiplying and dividing are inverse operations. But in math and in 8th grade, we're going to talk a lot about the y over the x, because that leads to slope next year. So what is the unit rate? Well, it is 40 cents per ounce. What does that mean? Well, for every ounce of froyo, it costs 40 cents. So it says Isabella's brother takes an extra long time to create his dish. When he puts it on the scale, it weighs 15 ounces. How much did his dish cost? How can you calculate this? Well, if he gets 15 ounces, I know I can multiply 15 times 0.4 to figure out the price he pays. And 15 times 0.4 will give me $6. All right, number 2 says, in the back of a recipe book, a diagram provides easy conversions to use while cooking. So here you're going to see cups and you're going to see ounces. For 0 cups, it's 0 ounces. For a half a cup, that's the same as 4 ounces. 1 cup, the same as 8. 1 1/2, the same as 12. 2 is the same as 16. So if this is my x and this is my y, they want me to look at my y over my x to decide if they're proportional. So here I'll get 0 divided by 0, which is 0. Here I'll get 4 divided by 1/2, which is 8. Here I'll get 8 divided by 1, which is also 8. The next one, I'll get 12 divided by 1 1/2, which is 8. Here I'll get 16 divided by 2, which is also 8. So are they proportional? Yes. And how I know is because y divided by x all equals 8. I can multiply my cups by 8 to find my ounces. So part B says, how many ounces are there in 4 cups? Well, because of what I just said, up above, we could do 8 times 4, 32. 5 cups would be 5 times 8, and 5 times 8 is 40. 8 cups, well, that would be 8 times 8, which is 64. So how do you know? I can multiply my cups by 8. All right. Down below it says during PE, Jose's class has to do some jumping jacks. Next to each station was this chart showing how many calories on average would be burned by completing the activity. So if time is my X and calories burned is my Y, all right, I know I could do 11 over 1, which is 11. 22 over 2, which is 11. 33 over 3, which is 11. 44 divided by 4, which is 11. So is this true or false? Are the calories burned proportional to the time? Yes. My Y over my X all simplify to 11 calories per minute. So if he jumped rope for 6.5 minutes, how many calories would you expect him to burn? Well, 6.5 times 11 equals 71.5. So 71.5 calories for 6.5 minutes. Number 3 says Alex spent the summer helping out his family business. He was hoping to earn enough money to buy a $220 gaming system by the end of summer. Halfway through the summer, after working for 4 weeks, he had earned $112. Alex wonders, if I continue to work and earn money at this rate, will I have enough to buy that gaming system by the end of summer? To check his assumption, he decided to make a table. He entered his total money earned at the end of week 1 and his total money earned at the end of week 4. They want to know, will Alex make enough money after 8 weeks to afford the gaming system? How do you know? Well, we always say earnings per week, right? So this is my Y, this is my X. If he doesn't work, he doesn't get money. Here, 28 divided by 1 equals 28. So I'm thinking he's making $28 per week. Here, I've got 112 divided by 4. If I type that in the calculator, I get 28. So my assumption is right. So that means I can go ahead and I can multiply 28 times 2 to figure out how much he makes in 2 weeks. 56. 28 times 3, which is 84. 28 times 5, which is 140. 28 times 6, which is 168. 28 times 7, which is 196. And 28 times 8, which is 224. Now remember, his gaming system was $220. So it says, will Alex make enough money after 8 weeks to afford the system? How do you know? Yes, because the system was only $220 and he has $224. So are Alex's total earnings proportional to the number of weeks he worked? How do you know? Well, yes. We took the number of weeks and we multiplied it by 28 to give us his total earnings. We could also do y divided by x, and we would get 28 each time. All right. So lesson 2 and 3 build off this idea of proportional relationships in our y divided by our x.